Hello, welcome back. As I'm going to say this on every video, but please watch the first one. It's much prettier and visual. The first few videos are going to be quite rough on the eyes. Not much to see, just like debug boxes and stuff like that. So hopefully the subject is interesting for some of you. But yeah, I think videos in the future are going to be much more interesting. But for now, it's just like the basics of the system, but it's important to start on a good base, obviously. So today is going to be super quick, hopefully, probably a 10 minutes video. So about generation, just wanted to show the basic structure of how I'm managing the data about the chunks and the map. So first of all, the map is managed by an actor I call the map manager. It's pretty obvious. It's managing the map, so it's holding a component which is actually going in the future to manage the meshes for the chunks. But right now it's kind of empty. It's just debug boxes. If you watch the previous video, the color of the chunks right now represent the LODs, but it's not important for today's video. And so yeah, generation. So you can go around this in many ways in a voxel-like game. In Minecraft, for example, the chunks are like big pillars. So you have just basically 2D chunks in a sense, like it's just in X and Y. You don't have multiple layers of chunks in the z-axis in the height of the map. This is not the case with this project. So the chunks, as you can see, are like boxes. So you can have, as you can see here, multiple chunks height. And if I move my player, as you can see, it's generating new chunks. And until you reach the bottom of the maps. And now I reached the bottom and there is no generation going on anymore. So you could just use that and generate the chunks around the player, and it will work. I've done something a little bit different. So the map is not only holding 3D chunks, so it's a giant map of chunks, but it's also holding something I call cells. So it's just 2D information about the X and Y location. So if I draw the debug cells again, oops. So now, as you can see, we can see new stuff appearing. Again, it's just debug. So these are 2D information. So if I move my player and generate stuff, so as you can see, so now the 3D chunks are generating, but these 2D cells are super fast to generate, obviously. Right now, it's not generating much, but it's actually going in the future to generate the surface 2D noise of the map. So the chunks themselves will not have to generate this surface information. The 2D cells are going to do it. So basically, it's a quick way to be able to share this information for all the chunks of the same X and Y location. So yeah, the cell is generated once for the XY location, and then this cell is actually, as I was saying, generating the height. So it's from this height, from this 2D noise, you can extract the min and max height location, and then from that you can know exactly which chunk you actually need to generate on the map, because as you saw at the beginning, you can have a lot of chunks in the depths of the map, so you don't want to generate all of that. Obviously, you just want to generate what you need, what is actually visible right now for the player. And if the player, like for example, digs or whatever, or explore the depths, then you can start generating more chunks. But for the initial generation, you just want to compute this min and max and just generate the chunks that you need. That's it for the cells. It's very quick. It's just to show you how I'm organizing the structure. And also, as a quick extra note, the 2D cells are also how I define what the player can see. It's much faster to just check the cells around the player rather than having to check all the 3D chunks in a 3D sphere, for example. So I'm doing some tricks with that, and it's much faster. And I mean, for one player, it doesn't matter really. It's fast anyway. But imagine you have like a multiplayer game with I don't know, like 50, 100 players. It's like, you know, if they're moving in completely different regions of the map, then it's important to be fast at this point, to not slow down the server. Anyway, so I'm going to stop with that and show you. No, actually, I can just stay here. And now I'm going to just debug generation. I'm going to talk about the generator subsystem I've made. So it's a subsystem. If you don't know what a subsystem is on an Unreal Engine, it's basically you know, like the game instance class. It's an object that exists for the whole duration of the game. So it's not dependent on the world, it's not dependent on the level that you load in Unreal Engine. It's going to exist from the start of the game until the end of the game. And so this generator subsystem is spawning one background thread for each physical core of the machine. So like, for example, my CPU has 12 cores, and as you can see, I have 12 generators, so from 0 to 11. And so as I drag around, you're going to see that this generator, you know, I just distribute the task to this generator equally as much as possible, obviously. So you know, it's nothing complex. But the thing is, right now you might be wondering why I'm using like an extra subsystem and not just doing that with the map manager, for example. And you're going to know that in a future video. Yeah, a little bit of teasing. But no, basically, no, just to tell you, it's because the game is able to load multiple maps at the same time. And you don't want each map to compete for the resource. So having a subsystem is going to allow all the map managers to not, you know, to submit to the same common subsystem. So you can just distribute tasks among different maps instead of all the maps asking for all the resources all the time. Yeah, so just a subsystem makes more sense in this case, because you have limited resource for your machine. You don't have limited resource for individual maps. Like, all the maps use the same computer, right? So you need to balance them equally. Anyway, so that was it for. Yeah, so I relaunched the game, and so I want to talk about priorities now for the generation again. So each task, whether it's a 3D chunk generation or cell generation, each task has a priority number. So by default, I set the cells to have a higher priority, because we can't really generate chunks until we have generated a cell at this X and Y location for this chunk. So yeah, cells have higher priority and chunks have a lower one. So if I move with the player, you're going to see. So all the purple stuff in here. So the priorities are, actually, sorry, I just need to debug the priority. Debug, generation, color. I think it's this one. Yeah. So now the color that you see are going to represent the priority. So the red ones are the highest priority. So as you can see, as I move, the cells generation above are the highest priority. And behind you can see the 3D chunk generation, which is slower, use a different set of priorities. And so, as you can see, all the chunks priority are not the same. So if you watched the previous video about LOD, you know that I'm generating the full detail of the chunk only around the player, closest to the player, and then these chunks in red are low res generation, not just for the mesh, but for the generation itself as well. So so that's why I'm also balancing priority like that. So I want the chunks closer to the player to be generated first, and then the other ones are of lesser importance, obviously. And so, yeah, as you can see, this is how I balance priority. And again, in the previous video, I talked about chunk activators component. So the player has an activator component. This is the reason why. Chunks are generating around them. But you could have other object generate chunks. And actually, I'm going to show something. And so, talking about priorities, I have this actor, which has two activator components. So it's a very big actor. It's just to show you the effect more more easily. So you have one activator on one end, which has a negative priority, and you have another activator component at the other end, which has a positive priority. So if I just play and drop this actor in the map, okay, so now if I start to move it, you can see that one side is generating before the other side. So it's just to illustrate the priority I was talking about. So yeah, it's working, obviously. So you have this side with the activator, which has the positive priority, and this side with the negative priority. And yeah, one side is generating faster than the other. So this is how you can balance priority. So for example, if you have player, obviously you want the players to have the highest priority. And if you have other elements that need to load chunks around them, but that are like not like critical to the gameplay, you can have a lower priority values. Obviously, it's as simple as that. And finally, before we end this quick video, I'm going to talk about chunk regions. And so, as I was saying, like we have the structure with the cells, which are 2D location X and Y. Then we have the 3D chunks in X, Y, Z. And then we have the cells, which are the regions, which are basically a 3D region of chunks. So I'm just going to draw them, so it's easier to see. Debug regions. If I start, okay, so now we just have one region generated. If I start generating chunks in another area, yes, you can see that the regions are created. Right now it's not doing anything, but it's basically mainly going to be in the future for the save and load system. So you obviously don't want to save one individual file per chunk. It's going to be a massive bottleneck, and you're going to end up with thousands and thousands of files on your computer. So no, you want to do this with batching many chunks at once. And so regions are an easy way to do that. So yeah, they just exist. It's super, like it's nothing. They don't contain anything. It's just basically a way to subdivide the world. And so the only thing I'm using right now with the region is something I call the background generation, the continuous background generation. So I'm just going to switch to a lighter debug mode for the chunks. Okay, so as you can see right now, I'm moving my player around, and it's just generating the chunks around them and nothing else, right? But if let's say the player starts to work on something in these chunks and doesn't really move around too much, so it's basically going to not use any resource for a long time. Like if I debug the generation again, so as you can see, like right now on the left, all the generator threads are empty. They are not doing anything. They are idle. They just wake up when we need some stuff going on, and that's it, done. So it's kind of wasted resources, and by far the slowest thing to do when you move around is chunk generation. But as you can see, if I move to an area where we have already generated the chunks, whoops, what did I do? Sorry. So if I move to this area where we already have chunks generated, like it's super fast to update. As you can see, we have we are just needing to reload some LODs because now some LODs are getting updated. But otherwise, like as you can see, the range updates immediately. Whereas if I start to move to another area, it takes a lot longer to load, as you can see. So why am I talking about that? It's because I made something called continuous background generation. So if I enable that and relaunch, you will see that as soon as the load is over, as soon as the generators are idle, you're going to see that I should debug region. As soon as the generation is over, in the background, the game is going to, little by little, generate chunks in the background. Even if these chunks are not used yet, they are not in range, it's just preemptively generating them. So when the player moves, it's already done mostly. And as you can see, if I move something else somewhere else, the background generation just stops and the priority generation takes over, and it's only starting again once it's idle. And as you can see, it's doing it per region, and it's doing it on the last region that was updated in priority, and then it's going to go back to the previous region. So yeah, it's just a way to speed up the process, and it's going to stop at the region's bounds. It's not going to generate the whole entire map. Unless you configure it to, but yeah, the chunks that are quite lightweight, so it's fine. It's not going to have a big impact on memory or anything. It's just going to be much better when the player moves around. It's going to be much faster to update, even if it's already quite fast. It's just better. So yeah, it's an option. You can disable it if you don't want to, but I think it's quite nice to have it. Right, I think that was it for this video. Hopefully not too boring. Next time I think I will be talking about replication a little bit, and networking, that kind of stuff. Thanks. See you soon.